Hey, hi everyone. My name is Kaushik. I'm today trying to solve the June Leetcode challenge problem. The problem is binary tree cameras, and the question number is 968. So this is basically a Leetcode hard problem. And first explanation of this question is here the tree node. There is a tree has been given to me where we'll have to install the cameras. And if we install the cameras, we'll have to return the minimum number of cameras we need to monitor all the node. And here from where it's the camera has been installed, from there that's the child, parent, and on itself it could be monitored. So let's watch it and how I'm trying to solve there. And before solving, I am giving an example of there. Suppose this is an empty, all are empty right now. If I've been putting that the camera in the first root child, in that if I putting there the putting the camera in this case, I can monitor all the node from the first child position. And same here also, if I've been putting the first child and the fourth grandchildren of the root, in that case basically, I can monitor all the node which has been present in the given tree node. So how I am trying to solve this problem, let's watch it. I am taking an example roughly, that is basically, suppose that, then that one, then that one, then that one, and it has another, and it has two child. So if I putting that value, and first of all, I am not putting the camera in the root node. Basically, if I've been putting that, will be uh, covered only in the just I mean that child node. So I am not putting that the root node. So if I've been putting, here is a camera, here is a camera, and here is a camera, and if I've been putting there, so that is been covered, that is been covered, and that is been covered, and that has been covered, but that one, and that one not been covered. So in that case, we'll have to install another 3 camera for here. So basically 5 camera needed there, but another solution also be possible there. Basically that one, that one, that one, that one, and that one, and that one. If I am putting the camera here right now, first I am not putting there, but right now I am putting there, that, so it is monitored from the root. Right now if I have been putting there and putting there, so basically that portion covered, that portion covered, that portion covered, and that portion covered. So basically all the node has been covered or the monitored. All the nodes are being monitored by the all camera. It means that all the nodes are being monitored right now, not all camera. So basically I am trying to solve there through there. I am first DFS call there and DFS call there. If I have been when it is goes, and basically that is an root node, but its parent node is basically none of them. So basically the null is equals to the parents, so it is also putting there. So basically if I have been trying to solve there, so my approach is basically, that if I have been putting there, hold on, I'm copying that value. My page has not been working here. Okay, yeah, it goes there. Yeah, if I've been putting that here basically, so in that case, I am starting from there. I am starting from the root node. And when I traversing from the root node, I am putting the basically that I will call the DFS call by one is left part and other is right part, right? And in the DFS function, I first check that, and in the DFS function, that is node, is I will first check there. Basically, that basically if the parent node is already present or not, already present or not, I mean that that's a parent node has been containing, I mean that when the left and right value has been putting there, then after that I will check there that parent is not null. First of all, sorry, parent is null. If the parent is null, in that case the top one case, and otherwise, and the otherwise and the otherwise case, I am putting all the value, and I am putting all the value if that is a first case. Then after that, when the left value has been going there, that is the root right now. So root is basically, then after that I will check there. The parent is basically, that's the, I will have to pass the parent also and the parent also, right? The parent, and check there. I am all the value when that was visited, all the value inserted into the set, and making or the installing and before installing a camera, I have to check that the parent is maybe null and the parent is present in the set or not. If that is not present, the child is not present, it means that left value and the right value has not been covered through the camera. Then after that I will, and basically, and also in that node also become not visited, not been visited, I mean that camera has not been not found or the not covered. So in that case I will insert all the value, that means parent, node, left child and the right child into that the set, and before inserting the set, I will increment the count value of the camera. So after all the traversal has been completed, when the all the value has been traversal has been completed, then after that I will return the count value. And for another thing is, suppose that is an child, and then after that there is null. So there is no record to check there. So if I have been putting from in the starting in the set that that null value, then it will also collecting that as an answer, as a new node that was not visited. So in the first we will have to push that the null is also a pointer there, I mean that node there. So basically there is the parent is null Parent is null. So parent is, when the parent is null, so I'll have to check there. So parent is basically null when the top one case, basically when the top one case, and after that I will check there. If the left part has not been covered, right part has not been covered, and as well as the pointer value, that the top value has not been covered there. So in to make that, that is an I am traversing all the node. There. So that's why is the time complexity is order of n, and the order of n there, because I am taking the set. So that's why the space complexity is up to order of n. But we can reduce there. But how? Sorry. But we can reduce there. Okay. So how is it possible there? Suppose there is a node, Suppose I put is a camera right now. So there isn't three condition basically possible. That is, either the node is not been covered, not covered right now, and node with camera, basically node with camera, and otherwise node covered with camera, and otherwise that is not covered with camera, it is covered by camera, covered through camera. So if I have been taking there from the, when there is an, basically I'll have to check, I'll have to make the DFS call from the root. If suppose that if the null value has been present, if the node is null, so it will directly return. So basically I have been initializing that 2 is camera present, and 1 is covered by camera, and otherwise that is 5, that is no camera there, So there is the 3 variable. I have been putting that all the condition. If I have been checked there, suppose empty case, so it doesn't require any camera. So basically it will make that is covered by camera. So that's why if a null has been present, null value present, so in that case I will return 1. And I will make that left value is an DFS of root left, and right is equals to DFS is equals to root right. That is making the recursive call right now. And after that what is found, if both are making 5, suppose that is not covered, that is left is 5 and the right is 5, that in that case that is not been covered, suppose, for according to that logic. So in that case I will install a camera there, and I will install a camera, and I will return that as a 2, that is camera present there. That node, the camera has been present right now, that the camera node, suppose in that case left is not that is null. In that case, if I have been putting camera, that has been all have been covered. So that's why I am returning camera been present on that node. And when the both their case, suppose the camera has been present right now, so in that case I will return that will be covered by on that case, and otherwise I will return 5. So I am trying to solve this problem, and I am trying to optimize. Yeah, basically the from beginning that was order open, they are also order open because all the node has been traversed, but the space complexity is reduced to order of h, basically the height of the tree. So I am right now trying to solve this problem as an implementation. That is, first I will make that, and one more thing, is basically that suppose there is a return, that is, suppose that is return something that is 0, but 0 could not be possible because if I have an empty node, suppose that node has been given, but there is node equal to there. So on that time, if the result is 0, sorry, in that case I'll have to forgot there. They basically basically the not 5, there will have to put a 0. Basically in that case it will directly return there as in 5. If I've been putting 0 there, that will be the if the 0 value has been found, so that I could be handled there. So what is thing there, basically if the 0, basically the 0 is the minimum, will have to one camera will have to install there, one camera will have to install that if the no camera has been found, so in that case, if the answer is coming 0, in that case I will install one camera, and otherwise what will return, that is the answer. So I am right now trying to implement there. So first I will call the DFS, that is root, and I call there, so integer, okay, I'll have to return that node basically. Tree node star root. If the root is null, in that condition we'll have to return what, that is the 1. What is 1? That is, the 1 is basically that is covered by camera, because I have to put there basically. Return 1. Integer left, I will call the recursive function right now, dfs root right, sorry, left, and integer right is basically dfs root right. Suppose if the left is 0 or the right is 0, that means that that's not 5 basically. No camera has been found, so it not been covered, no camera has been found, it will not been covered. So we'll have to initialize the camera there, that is cam plus, sorry, I'll have to initialize the cam value. And plus, else if the left is 2 or the right is 2, that means it is covered, that will return 1, and otherwise I will return that is 0. So we'll have to check there. If DFS is equals to 0, then return 1. Otherwise, okay, I'll have to mix not semicolon. Integer answer is equals to, yeah, basically not 1, basically that is in cam plus 1, that is in cam plus 1 return, that is in cam plus 1, basically that 1 also, and otherwise it will return the cam. There is no record to the answer value. We'll have to put the value, we'll have to run the code right now if any compile time issue or not. Yeah, I found. Okay, found line number 22. Okay, I missed the T. I am repeatedly running my code. Yeah, same here. 38. Okay, else if else if, okay, return null. Okay, then I will return, else part will be not required because for the previous part that will be returnable. It gives the wrong answer. Okay, this condition. Okay, return 0 basically, but which condition it running false? Yeah, 37 line, basically it gives the wrong answer. Okay, if the node is equals to there, basically that one. Okay, I forgot there, sorry, forgot that, that's the logic. So we'll have to camera been present there, we'll have to forgot there. Now I'm trying to run my code. Is it running or not? Yeah, it's accepted in run code. I'm trying to submit there. Yeah, it's got accepted. Thank you so much.